Okay, so for today's lesson we're going to be looking at rotation and inclination of right solids, and in this example it's a cube. So here we have on our sheet, we're looking at the plan of a cube, which is shown here, annotated A, B, C, D, and we're asked to draw a front elevation, an end elevation and a plan of the cube. This, as we can see from the drawing, it's rotated 30 degrees to the vertical plane, and what we're asked to do, the bottom face of the cube is inclined at 25 degrees to the horizontal plane, and the edge BC rests on the horizontal plane. So the first thing we need to do is we need to draw a thumbnail sketch on our sheet somewhere, and we need to annotate that drawing and correspond it to the annotations we have on our plan view. So BC represents BC here on our sketch. So following that, we're going to project an auxiliary elevation from our plan. So the first thing we do is we're going to draw a line perpendicular to the line BC, x1, y1 line, and then we're going to project our points perpendicular to this from the plan view. We're going to take our point BC on the auxiliary elevation and we're going to rotate it 25 degrees to the line x1, y1 line, and the length of this line is the same as the line BC, which is a true length line as it's resting on the horizontal plane. We can now complete the auxiliary elevation. As it's a cube, all the angles are 90 degrees, and we can annotate it corresponding to our sketch over here that we made earlier. We can now pause the video to discuss why we project an auxiliary views perpendicular to the line BC and why this is true inclination and true shape. You can use your augmented reality barcode to help you visualize this along with your 3D model. We now want to complete our plan view. So first step, we project our lines back from the auxiliary elevation to the plan view. We can then complete our plan view by joining our lines and annotating them as shown here, corresponding with your thumbnail sketch that you made. The next step then is to complete our elevation view. So we need to project our lines up from our plan view perpendicular to the XY line as shown. We then need to transfer and find our lines then in our elevation view. As the line BC rests on the X1, Y1 line, it's resting on the XY line, so we can just join up our point BC, and there's one of our lines in the elevation view. You can pause the video now to discuss reasons why we take our heights from our auxiliary views to complete our elevation. Once we have our views, our points found from our auxiliary elevation in elevation view, we can join those points up to complete our elevation view. It's critical that we can annotate following from our thumbnail sketch we've completed earlier. The next step is to complete our end elevation view. First thing we need to do is to draw our x2y line, which is perpendicular to the xy line. Project points then across parallel to the xy line to intersect the x2y2 line. Project lines then 45 degrees from the x2y2 line up to intersect the xy line. Following that, project those lines up vertical. The corresponding lines projected across from the elevation view where they intersect are points on the cube. We then join up these points to complete our end elevation view. You've now completed the elevation plan and end view of a cube which is rotated and inclined to both principal planes.